Alright, let's take a look at this problem. Count binary substrings. Give a binary string s. Okay, actually it is given. Return the number of non-empty strings that have same number of zeros and ones, and all the zeros and ones in these substrings are grouped consecutively. Substring that can occur multiple times are counted the number of times they occur. So there are 6 substrings that are have equal number of consecutive zeros and ones. So this is a substring, this is also a substring. We want the unique ones. Oh, okay, so these are actually okay, so maybe if we implement some sort of if you take a look at this one, just 1 second. If you take a look at this one, there are 4 substrings. We have it like that. What about this? This is substring, right? Okay. That is not a valid substring because all the zeros are not grouped together. Okay. So simply in our answer, ones and zeros are grouped. So they're either okay, so the substring can be 0 1 1 0 0 0 1 1 1 1 0 0 1 1 1 0 0 0 0 0 1 1 1, right? Okay, so it is just like a mirror, like half of it is 0, the other half is 1, so it's always like that. So when I see 0, I check the next one. When I see 0 1, when I see 0 0 0 1, I move here, and then when I have 1, there is nothing. I see 1 1, you have 1 1 1, and then you have 1 1 1 1, 1 1 0 0 1, and then now it doesn't work. Come here, check this. So it's like a sliding window, but normally, yeah, I guess if we want to do a brute force way without sliding window, then actually I think there is also a way of dynamic programming way to do this, but for now maybe let's implement the brute force and then optimize it. Okay, so these will be the substrings, possible substrings if they are in. And for that, so if with the brute force we start with every character, just go for every character, we see if there is like if it is possible to have half. But for that we always, this is always length is always twice, actually length is always even. So we check this for that. Length is like that, right? Okay, if I have some sort of function to check this. I guess so. When I encounter 0, I go until I see 1, and I see the length, and I check if the remainings are like same. And to check that, it is pretty easy to check it. Right, from here 1 until 0. Okay, from 0, and from 0 I also count. And if the 0 count is now less than 0, it is fine. Okay. So my steps will be first, I have to so my approach would be brute force, and starting with that index, search for next difference while counting next difference. Yeah. So for instance, if I start with 0, I start with 0, and then next difference is simply 1. And when we encounter that, we have I. So I will be here, j will be here. The difference is the number of length here, and we simply look for j plus like that the other one, the other right, the other starting one. And for that, but if we don't have that, we only have 0. In that case, we just count that, and we have to stop immediately. I mean, if I have some sort of function to check this, right, I guess that would help me. Okay, I guess I just want to implement it immediately and then think about it later on. So normally I will explain it and go on over this, but actually I can also do that. Search for different. We have j minus I. We have like current character. Current is equal to s dot I. Now we search for different. Is the length. So search between j plus j and j plus length. If that length is equal to, if there are that many same items, that many like inverse of currents, return count plus plus. But is it like, maybe there is a better way to do this? What if I have some sort of let's see. Oh, wait, actually, from here I go left, right. From here I go like this, like that. From here I go like this. From here it doesn't work like that. From here it works like that, and it also works like that. Wait, this can work like O of n. So if we have some sort of check there, it's much simpler from that position. From that position, I check that, and then that. It goes on like that. I give, so here, okay, I think this is much simpler. Now, if I give I should check j, and then, yeah, it should be just opposite of I. If not, I just stop. And then, so I do the same thing here. If it is same, I just keep going, and then now I do it like this and discover it like that, and it works. So I guess this is much simpler. So if I have some sort of a function, so I need a function define count, or like spread function takes an string and I, and also, I mean, I don't need counts, but I will give up count, or actually no, I'll also just have I, right? I have non-local count. I'll have my count here equal to 0. Here at that point, my current dictionary yeah, I'll have my dictionary there, which is alright. I will have my dictionary like this. Okay, 1 is 0, 0 is 1. So, okay, my current is int si. Okay, my current is at this position, it is 0. So my opposite is equal to dictionary currents. There's my current and opposite. Now I check. I have j, so I is that j is equal to I plus 1, and while j Sj is equal to opposite. We keep going, increase I minus 1, I minus 1, j plus 1. But here we also have to check if we also here I should be and I should be greater than I should be greater than 0. If it is 0, we cannot go there, and j should be less than length of s. Alright, so these are my things, and here I will count plus equal 1. Alright, so this will count it. So I is here, j is there. Doesn't work. I increase I, j is there, it increase the count. Now I is here, j is here, it increases the count again, and also the s si should be equal to current, and yeah, it should be like that. Actually this should be yeah, I should probably have these as 0 and 1 like that. I shouldn't convert this to integer. Opposite is that, si current, sj opposite, like that. I continue, I count, it goes on like that, and so I'll now have a function here. I'll just go over it. Actually, this doesn't make sense anymore. Here I'll have for loop starting from 0, which is like this. I in range length of s, and we call spread I, and yeah, like that. Return count. Right. Says string out of range. Oh, because I should have this just before this. Okay. All right. So right. We increase count, do it like this. Increase count, do it like that. Okay, why is it not working? I should be greater than that. Maybe print ij. See, I have 0, 3. Okay. Hmm. 1 and 2 count. Okay, 1, 2 count, 3, 4 count, 0, 1, 2, 3, 4 counts. But wait, I can be also equal to that. This cannot be equal to that. Okay, now it works. Right. Where is it? Okay, let me also change that. That's working. Let's test this like that. Okay, cool. Let's submit and see. All right, so let's take a look at the count, the actual complexity of this. So I just go over n. So this is of n. But every time when I go over it, just a second. When I go over it, I also go left and right. So, stop when they stop. I'm kind of computing everything again, which is redundant, but it should be at most. Should go at most of n divided by 2 times, but every time it is smaller. I think this should be of n because this value is at most of n divided by 2, but it will just happen once, and most of the time it is much shorter than that. So it will be like, for the first one it is 1 plus 2, just 1 second. Okay, so it will be 1 2 for the first one. It won't go in loop. Second one, third, 4. It goes on like that until n divided by 2 at most. This is the worst case scenario, which actually cannot happen. And then it goes on like that. So this is from n times, actually n divided by 2 times n divided by 2 plus 1 divided by 2 divided by 2. So n squared divided by 2. That 1 to n is n squared. I mean, the average case is of n, but I think the worst case scenario is of n squared because of this while loop. But I think it is like kind of impossible. The most you can get from this function would be n divided by 2, which is n squared, but worst case scenario is n squared. Yeah, the worst is n squared, n times n divided by 2, but yeah, it's just n squared, and on average it should be of n. Because the best case scenario is of n, and the worst case scenario is of n squared, and that's the only one case. Yeah, I think this should be of n squared for now. Actually, let me check the discussion and then maybe go over it again. All right, so this is the other solution, and it is basically storing the number of groups of same elements previously, just before the current I. And how it is doing that is, so we have I here, so we increase it, the current, we have answer, we have previous, we have current, so we increase I and we increase current will be now 1, and then when we increase I again, we see that it contradicts with the previous. I mean, it is the opposite of the previous one. So we just go in and we say the previous minimum of previous and current, because the current is now just 2, and the previous is just 0, and because of that, so maybe just put it here, the answer, like that. So we have 0 added to our answer, but then later on what happens is that we change current to 1, but our previous is now 2. It is 2 because we counted 2 zeros there. Now our previous group is 2 zeros, and we move on and we increase the current by 1 in each iteration. Here we later on increase current by 1. Now it is 2, and then when we increase it here, actually current was 1. When current was here, it was 2. When we come here, we see that current is now 2 and previous is 2. We take the minimum of them, because if this is like 3, if this is like maybe 3, we can only form this, right? So we just add that one, and then what happens is that we add this 2 because there's 2, 1, and 2, and also we again swap it, and then so when we are moving, we're increasing the current twice, and now current is 2 because we have our current 0 here, and then our previous is now this 1 and 1, and because of that we add 2. Because of that we add actually we add 2 from here, and then we add 2 from here, which is 4, and then we add 2 from here also, which is now which we add 4 from there, which is 6 now. But just a question here. Okay, I'm a bit confused. So when we have I here at this position, we just at this position they are not the same. We go in. The current is 2. Previous is 0. We continue like this. Now previous is 2. Previous is this one, okay, and the current is just before group, and then when I increase our previous group, current group is also this is 2, and this is also 2. We add that one, so we have 4, and one more. Our previous and current group now is 2, 2. We add and make it 4. And because of that, yeah, it is now 6 actually. This, yeah, that's better to show it here. So we add answer to it, and now at the end we add the last one in the end. Okay, so because of that it is just working as fine, but it is just O of n times, because this is O of n square. All right, so that was it. I'm just gonna close it now.